So yeah, hello guys. Welcome to the third session of PCB designing. Please let me know I am audible to everyone. Please write yes on chat if I'm audible. Yeah, okay. So I will be briefing the last session because this session will be connected to the last one. So yeah, if you want to create a new project, then go to File, then press on New, then click on Project. Then enter the location where you want to save your project file. Then just type the name of the project. Like last day we had written the water level indicator and we had defined some location. So we had saved there only. Then I defined you something like extensions. Yeah, last day I told you dot pro is the project file where all the schematics, your layouts, your netlist, your Gerber file will be stored. Then comes your .hch, which is your schematic. Then comes your KiCAD underscore PCB, which will store your design layout, or you just say design of the PCB. And we had discussed some shortcuts like if you want to move your either your component or your text of the component, then you will press M by you will press M by placing mouse on that component or text. And this is for to move. Then if you want to edit, then you press E. And press E and press E by placing mouse on that component. Sorry for the spelling mistake, or text of the component. And if you want to rotate, then press R along again by placing your mouse cursor. If you want to copy, then press EC. So if you want to move, then M. If you want to edit, then E. Edit the properties of the component or edit the value of the component. And then if you want to rotate any component or you want to rotate any text, then you will press R. And if you want to copy, then you will press C. So that's it for the last session. Now we will move forward. Yeah. Again, double click to access the schematic file which we had designed yesterday. We will double click on the water level indicator.hch. HCH means the schematic file. Here the schematic file will be opened. So here there are question marks. We have designed the schematic for the water level indicator. This is our cursor. This is our BC5473 transistors in a 4 quantity, resistances with a 220 ohm in a quantity of 6. Like these are 3 and there are 3, and LEDs in a quantity of 3, and a battery like we will define a battery. I think the battery was 9 volts. So I am placing my mouse cursor on battery and just pressing E. And now I can able to edit. So if I want to write the value of the battery, then I will type 9 volt. So it will show you in the schematic that the battery you will put in the schematic or in the hand in PCB, the battery should be 9 volt. Now at the last session, I told you we will do the annotation. Today we will design the real water level indicator, which you might have seen that red colored. I will show you once we will start designing. First, we have to remove these question marks. So to removing the question marks from the value is called the process called the annotation. Like we will annotate all the symbols available in the schematic. Here is the this is the denotation for the annotation. Like annotate schematic symbol, it is written. So we will click on this. Use if you want to. If there are some schematics which are very complex, so to not to make on a single page or single sheet, designer used to design those schematic in a multiple sheets. So there are options that you want to annotate the entire schematic or the current page only, and if the annotation has already done, you want to keep that or reset that. There are many options in this. And the order, sort components by the exposition. There is a design given that if you want to annotate in an order of exposition, like from top to bottom, then moving from top to bottom, then you will click on this sort components by exposition. If you want to sort components by y position, like from left to right, then again from left to right. If you want to choose any of these, you can. So I'll press on annotate. You can see clearly this question mark will change into some number. You can now then press then I press close button. Now every symbol has some question, every symbol has some number defined. Like if you want to count, if there is many complex circuit and there are many number of components, and you want to find how many of that component has the quantity. Like if I'm using the BC547, then I can see that Q1, Q2, Q3, 4, Q4. Now I am pretty sure that there are four quantity of BC547, and at the same quantity R or resistance of 220 ohm will be the 6, diodes will be the 3, and the buzzer will be the 1, as it is shown that the BZ1. If you can edit, you can also write BUZ1. BUZ1. So we are done with the annotation, and our schematic is officially complete. So I don't think there is some addition or you want to do some edits. So now after doing this, these are the symbols or the layers or designs or the steps we will do one by one. First we had done the annotation. Now we will do the assign PCB footprints to the schematic symbols. Yesterday Mohit Gupta had asked how to define the through hole component or the SMT component. Here is a step, here is the answer of your question, and this is the step where we will define. Just ignore this error. I'd made some issues in the library. Rakshit has asked question. Don't we need to mention the units? It's only depends on you, because the schematic is just for you only. There is this schematic is not to be sent to the manufacturer, or yeah, it is not sent to them. If you want to write the uh, values or the units, you can do so. If I want to put the resistance of 220 kilo ohm, then I will edit this again and write 220k. Yeah, that's it. So yeah, I think you are clear? Yeah. So now we have to do that assigning the components. Yeah. Now battery, for battery 9 volt. Have you all seen? I think you had all seen the Arduino Uno, and it has the barrel jack on one corner. I'd shown you. I will show you that. Yeah, this is the barrel jack, DC barrel jack, or you can say 9 volt DC. 9 to this on this Arduino Uno board. This barrel jack can control or can allow up to 12 volts. So we can put the input voltage from 9 volt to 12 volt. So in this case also we will put this barrel jack. So yeah, we will find these are the footprint libraries. These are the symbol of the footprints, and these are the filtered footprints. I'll show you how it will work. For this BT1 battery 9 volt, we have to find the connector, that barrel jack. Here it is written that connector underscore barrel jack. We will click on this and just choose these filtered footprints. If you want to see before assigning, if you want to see how footprint looks like, then you can click on any of the footprint you want to see, and here clicking on here view selected footprint, click on this, and this will show you how the footprint look like. So this don't want this, I think. Yeah, this is the only barrel jack which is used in the Arduino Uno also. So we will put this barrel jack on our PCB2. So just double click here we had not assigned any footprint yet for the battery 9 volt or BT1. So we will double click on this, and now we had assigned. For buzzer, again we have to find the footprint library. For this you can put have you seen the buzzer? First I had shown. Yeah, buzzer, this I think this buzzer. So this buzzer has two legs. So if you will put some connectors, two connectors, and just solder these connectors with the two legs of the buzzer, then your connections of the buzzer will be done. So yeah, here the positive leg and the negative leg, this will be the positive and this will be the negative leg. So we will be choosing a connector of a two. Yeah, it's up to you if you want to choose the horizontal or the vertical connector. Yeah, so I am choosing the vertical connector. Yeah. For LED, we have to find the LED just pressing L. Here is your answer, Mohit. It is clearly mentioned that if you want to choose the LED SMD, like surface mount LED you want to choose, or you want to choose the THT or through hole technology LED. So for this beginning project, we will choose the through hole technology. Yeah, I'll be choosing this for all the three diodes. Yeah, and for the resistance, again we have to choose Either we want to have the SMD library or the THT library. Again, for the first project, I'll be choosing the THT, and here we can see we're doing some. I'll go with this. Yeah. For all the resistances, I will be using the package DIN0207. So now we had assigned all the components, all the symbols with their footprints. Like this is the window which will assign every footprint to every symbol which we had used in our schematic. So just apply and save schematic and continue. It will show that you have saved the schematic, and just press OK. There are two questions. Advantages क्या होते हैं SMT versus THT में? It's all depends on you if you want to choose the SMT or the THT, depending upon the area of your PCB. Like if you have small area of PCB and you want to make things smaller and smaller, miniaturized. Like if you have an area of 20 by 20, then you cannot make the PCB of 25 by 25. Then you have to put your components in smaller or miniaturized way. So that miniaturization can be done from THT to SMT, like from through hole technology to surface mount technology. So that's the only reason behind this. Now we are done with our assigning. Then the question arises, now we have to generate the netlist. I'd explained in the first session what is the netlist. Netlist is the just the it will tell you which component is connected, which symbol or which symbol used in the schematic is connected to which footprint in the design layout. Along with the location we will be assigning in the design. So just click on this generate netlist. We are designing the netlist for the PCB new. Click on generate netlist. It will ask the location, and it has the extension of .net. Now our file name would be water level indicator.net. Just click on save. Now I show you this. Yeah, this is the .pro, which is our project file. Now it will having the .kicad underscore PCB .net .pro .hch and .lib. All these files will be stored in the .pro extension. So first I'll be showing what I'll be designing. Yeah, this is the design we will be designing right now. It's all up to you if you want to design the same or not. So I'll be designing this design. So how to design, I'll show that. Just we had generated the netlist. Now it's time to design the PCB. I'll all answer the questions which you had asked after completing this session. So the first step of designing the PCB is to design the board layout. So for designing the design board layout is designed in the layers, in the specified layer. So this is the PCB design window where you will design your final PCB, and you can see your PCB in a 3D view. If you have multi-layer PCB like 4-layer PCB, 6-layer PCB, you can also see all the layers in a separate view. So for this is f.cu is your front copper layer, like top layer. B.cu is your bottom copper layer. Again, all these are the layers, and in the board layout designing, we will be using the edge cuts. This is the specialized design or specialized layer which will be used for designing the layout. Add graphic lines. You can see a white circle here. This white circle shows you your two-wire connection or any two things connected successfully. Now I will do some designing things. Again, I'll for edit anything. Now I want to edit this line. So I'll just place the my cursor, click on this yellow line and just press E. Now I can define the start position and the end position of this line and even the line thickness. I want to change the line thickness to 0.1, and to make the line straight, I just want to put these two things at the same level or any same value. Like I'll put it 55, and for this two again 55. Now the line is straight. Now if the manufacturer or the designer wants to design a particularized design, like I want to make this thing as you can say 70 mm or 100 mm length, 100 mm length. So we will be designing that thing too. So I'll design this length in some 70 meters. 70 meter, I think it will be enough. So I'll start with 74 and adding it to 70. It will give you, I think, 144. Yeah. Now our length of this water level indicator is 70 meters. 70 meter plus our electronics which will be placed here. So for, and the separation line, this is the separation line between the two lines. Again defining this. Putting this on the same value to make the line straight. Now line is straight. Now I want to join this thing. Just now I have to join these two lines and move this line, move this vertical line to get joined to this horizontal line. Just press M. When the white circle comes, just place that line there. And I want to make the difference between these two lines as I think 25 mm will be the better. So the starting is, I'll say 80, and 25 will make it 105. So I'm not writing here 105 because this is the starting value and this is the ending value. So I'll be putting here 55 is, I think, 55. Yeah, it's 25 mm only. Okay. So now I will clearing this line. Join these two lines, just press M, and place here, and when circle comes, the line is joined. Now I have to make this as I think we have done 70 longer, so I have to make it 70 Again, this will be 144. Yeah. Now this part is done. This longer part where the water sensor is written, this part is done in our PCB. Now we have to make this design. I think the designing which I am doing is clear to all of you. Then press M. I think we should make this line something shorter. So we should say 58. We are making it 3 long. So if you want to copy this line, just press on this line and click on this line and press C. Or you can the next and the alternative is to make copy here and just paste here. Now it's time to make this thing. And we have not tilted this line here. We have some tilted portion. So we will tilt this line. Just to tilt this line, I'll make some hit and trial values. 150. 150 is somewhat 148, or you can also say 147. Like I'm making 3 Okay, so same thing I'll do here. Yeah, that tilted portion is done. Now I have to put this line. That should be line 158. I'm joining these two lines. Just copy this line. Okay. This is again done. You can delete this extra line. Now again we have to make a tilted connection. As shown here, we are done with this part. Now we have to design this part. Now we want to make this tilted portion. We can use this tilted portion and rotate. I'll show you how. Just copy this line and just paste somewhere else. Let's just click on R. Now it is rotated. Yeah. Now you can again copy this line, paste here, and again you have to rotate. Just press R. Now our PCB layout is somewhat complete. Deleting these two lines. Now we have to make this portion. Taking this line, pressing M and placing from that position to this. Editing this line 0.1. Straight line. We will have to make 169 of 169. Please turn off the mic. I think I did not change the line thickness. Just place here and connect it. Just copy this, paste it here. Yeah. And delete this line. Now we have to connect these 2 points. So we have to know this position, or first I'll edit this coordinates. What are the coordinates of this point and what are the exact coordinates of this point? So we can edit this line. So the start x is 174. This coordinate is 174.84 with y coordinate as 55. Now I have to check the coordinates of this line. The starting coordinate is 168.84 with 80. Now we will have to put this this vertical line's end point is we should be connected to the horizontal line start point. So I'm making that. Yeah. Now it is connected. So yeah, our PCB layout is ready. So if there is any error, how will you check those errors? So earlier I told you if the connection is not done properly, then only you will the error will show up. How the error will show up, I'll show you first. First, we will see the 3D view of this PCB. This is a 3D view. How your PCB will look like. Here you can see after putting all the components which we will place tomorrow. So this is the PCB, how the PCB look like after you have the production of this PCB. So I'll show you what errors should we make. Now these two lines are not connected. Now I'll again press view, then 3D viewer. It will pop up with a unable to find the segment with an endpoint 74 mm with 55 mm. So this is the error, how the error will shown like this. Again we will put this thing, again we will go with this and 3D view. Yeah, now our PCB is ready. So yeah, that's it for today. I think today's session will be somewhat interesting or somewhat, yeah, I done with this. Rakshita, does it matter which footprint we select for a particular? Yes, it does matter. Yeah, irrespective of the footprint, we know which component to place there. Yeah, how can you place if you are ready with your PCB? Now you have to place the component. So if you don't know which footprint you had taken corresponding to your symbol, then you are not able to put the symbol on your footprints or on your yeah, on your footprints which you had aligned or you had assigned with your symbols in the schematic. What if we don't find the suitable schematic? How do we create one? Yeah, that's the again a study. If you are good in analog and you are good in digital, then you can make your schematic on your own or design your circuit on your own. And the best way to design the circuit is to study corely the data sheets of the components which you are using in your schematic. Don't you have the option to extend the line? Yes, ma'am. You can extend the line by just clicking on the one side or which side you want to extend. Uh, you can place this side. I show you how. So if you want to increase the length of this line, just hold this white marker and just place this. Now your line is extended. It is connected to this point also, and your length of the line is extended. This is how you can, this is the alternate way. One way is to put direct the coordinates. I used to use the coordinate thing because it will give you the exact values where you have to join the two lines. So yeah, this is you can do so. Anyone has any questions, or you people might have many questions for today's lecture, or we will give the task or the test. So no questions. Yeah,
It
I
is
just
necessary.
making it just to show you people, show the how things will go in this design PCB. And if you want to make it straight, you can make it straight. Or if you want to make a different design, if you want to make a square, if you want to make a circle, if you want to make any symbol you want, then you can do so. Yes.